Hello, my dear friends. Welcome back to another MS SQL class. And in this class, we are going to see how we can analyze and improve the output response time of certain search queries using some methods like indexing. Okay. Now, for example, I'm here. If you remember this class 1 database we had created initially. And under this database only, we have got our various tables which we can use. Hmm. Now use this class 1 so that we can gain access, execute, and the commands are being completed successfully. Okay. Now if you come back to your original table, that is under this database class 1, we had our original table emp2 underscore 2. Okay. So select asterisk from emp2 underscore 2. If you select and execute, then you will see the original database, that the database that we had been working upon will be displayed. So it has been displayed here. For example, see this was an employee database consisting of 132 rows. If you see, look at the bottom right corner, 132 rows are being displayed because we had 132 employees in this particular database. Okay, the various fields were like EID, consisting of the employee IDs of employees, name field consisting of the names of employees, then address one, which corresponds to locality, signifying the localities of the employees, address two, the particular addresses of the employees, the city names to which the employees belong to, phone numbers of the various employees, email IDs of the various employees, date of birth of various employees, date of joining of various employees. Okay. So if you look at closely from lines 4 to 5, then select asterisk from emp2 underscore 2 will mean that display all the fields. Display all the fields or all the columns from this table corresponding to what? Corresponding to wherever your city value is Pune. Okay. So select asterisk from emp2 underscore 2 will ensure that all the fields from this particular table are displayed. Wherever the city value is Pune, only those specific records will be displayed. So execute, select 4 to 5, lines 4 to 5 and execute. And you see that is the 50. If you look at the bottom right corner, there are 58 rows. So that means there are 58 employees who belong to the Pune city, like Sandy Sharma belongs to the Pune city, then Rohan belongs to the Pune city. So like this, there are 58 rows where we have the Pune value under the city column, means 58 employees belong to the Pune city. That's what we were encouraging for, that only those records display only those records along with all the fields from this particular table, only where the city value is Pune. Okay, nothing else. So this kind of an operation is known as a full table scan. This kind of an operation is known as a full table scan. Why a full table scan? Because here, as soon as I'm running this query, what is the motto of the query here? To conduct a search operation. Search what? Search the city column. For which value? Pune value. And whichever row corresponds to the Pune value, that row will be selected. So in this way, 58 rows got selected and got displayed. So the SQL database engine, it will basically go through each and every row. The SQL database engine will come to this table and it will go through each and every row of the city column. Okay. If I return back to this original table, my original database, huh? So the SQL database will arrive to this table and will come to the city column, and then it will basically try to locate the value of Pune in each and every row under the city column. Comes to the first row. Will it be able to locate the value of Pune under the city column in the first row? The answer is no. It is Delhi, not Pune, in the first row. Then SQL database engine will come to the second row and it will look for Pune, and yeah, it got the value of Pune, so this row will be selected. Then it comes to the next row. Here it will try to find Pune. Here it will try to match Pune. Is Pune there? No. So this row is discarded. Similarly, here it tries to look for Pune. Pune is not there. So this row is discarded. Here tries to look for Pune. Pune is not there. So this row is discarded. In this row, when it comes, then here it says that, yeah, Pune is again there. So this row is also selected. So this row got selected, this row got selected. Okay, entire row along with all the fields. And in this way, it will look through each and every row. The SQL database engine will look through each and every row. That is, it will navigate through each and every row of this table. And ultimately, those rows will be selected where the city value is Pune. So that is why it is a row by row operation. That is why it is known as a full table scan, because here the SQL database engine will conduct a row by row operation. Okay. So row by row operation is generally considered to be a slow operation, especially when the database is pretty large. Okay. Here when the SQL database engine goes through each and every row to find out the value of Pune, then for our database, it won't be a big problem. The output response time will be normally fast because we have 132 rows. This database I created hypothetically just for explanation purpose. Okay, but in reality, you may encounter certain databases where the database is pretty large. You can have 50,000 rows, you can have 1 lakh rows, you can have 200,000 rows, you can have 800,000 rows, you can have 1 million rows. So in that sort of scenario, if the database is that big or that large, and you are trying to conduct this kind of a full table scan, then can you imagine that how many rows the SQL database engine will have to navigate through? Suppose, hypothetically speaking, assume that there is a database where it has got 1 million rows, and I'm trying to, run this similar query where I'm trying to display all the records from this table wherever the city value is Pune. So the SQL database engine will conduct a full table scan where it will go through each and every row of this table under the city column, try to look and find out the value of Pune. So it will have to navigate through 1 million rows. So definitely the operation won't be a very efficient one. It will be an inefficient operation, slow operation. Okay, because of the size of the database. In our scenario here, the operation is normally fast because we have 132 rows. Okay. So to counteract this kind of an issue, there is a method known as indexing, which is used to counteract this issue of full table scan, because the full table scan becomes sluggish whenever we go for large size databases. Okay. So to counteract that issue, we have something known as indexing method. What is the method of indexing? The indexing is a method by which we can, create an index on a column of a table. Indexing is a method by which we can create an index on a column of a table. What is the purpose behind it? The purpose is to use that specific index for search operations to ensure that my output response time is fast. Okay, to ensure that my search operation becomes fast. That is the main purpose. Okay, so the main purpose of indexing is to create an index on a column of a table so that we can use that index to fasten up or accelerate our search query process so that our output response time improves. Okay, now what is the logic behind it? How to commence with it? Go to line number 9. Here you have to use this command, create index. So I'm giving command to the SQL that I'm trying to create an index. Whenever I'm trying to go for this kind of a command, then it is known as your explicit index. Okay. Under index, you have two classifications. One is known as your explicit index, another one is known as your implicit index. Explicit index basically means where the user is explicitly creating an index on a column of a table. So here I am the user and I am giving an explicit command to the SQL database, that is create an index. Okay. So under index, there are two types of classifications. One is explicit index, another one is implicit index. Explicit index means when the index is created explicitly by the user on a column of a table, and implicit index means when the index gets created implicitly, automatically, inherently. No intervention of the user is required. But in case of explicit index, the user is explicitly giving command to the SQL that, yeah, I am going to create this index on a particular column of a table. Okay, so that is known as explicit index. So give this command create index. Then you have to give a name to your index. Like I have given as quick underscore explore. You can give whatever name you would like. Then on, and on which column I am trying to create the index, on the city column. This is my target column where the search operation will be done. And the city column belongs to which table? emp2 underscore 2 table. Okay. So as because the city column is my target column where the search operation will be conducted, hence this you have to specify inside this parenthesis, and also you have to specify the particular table to which this column city belongs to, which is my emp2 underscore 2 table. Okay. So the command at once is create index. Explicitly I'm giving command to the SQL that I'm going to create an index, give the name of the index. Okay, give the name of the index, which is my quick underscore explore, and then on, you have to give this keyword on column within parenthesis, which is my city column, target column where the search operation will be conducted, and outside you have to give the table name because the city, this column city belongs to a particular table, which is the emp2 underscore 2 table. Okay, so explicitly I'm creating here this index quick underscore explore, which is my explicit index. Execute, commands completed successfully. Now I'm going to run the same query search operation, that is select asterisk from emp2 underscore 2 where city is equals to Pune. So same thing, just like here under the full table scan we did, here also the full thing, here also the same thing we have to do. Select asterisk from emp2 underscore 2 where city is equals to Pune, display all the records from this table wherever the city is Pune. And this query search operation is expected to be slightly faster than the full table scan. So execute is, you can observe there is a slight millisecond of difference between this explicit indexing method and the full table scan method. Under the full table scan method, we went for the search query operation. It may have taken say 10 milliseconds of time, and when we perform this query, when we performed, it was under the full table scan. At that point of time, we had not created any kind of index. Now we created the index, which was quick underscore explore, and we ran the same lines of code, the same query we run for such operation, and this time it gave the output a little bit faster as compared to here. The same lines of code, but here it may have given the output in say 10 milliseconds of time. Here it may have given the output in say 5 milliseconds of time. Since this database is consisting of 132 rows, hence that distinction won't be clearly visible, but in the backend, that's how it works, abruptly speaking. Normally, for 132 size database, our full table scan is sufficient enough. But I am explaining this concept so that you will be able to deal with large size databases when dealing, say, with thousands of rows or millions of rows. Then you would need a much more faster output response time. There is a much more faster search query operation you would need. So that is why I'm explaining this concept of indexing. Okay, in case of 132 rows, this distinction may not be apparently visible. Slight few milliseconds of difference might be there, where my explicit index is supposed to give a much more faster output as compared to the full table scan. That is a faster output response time as compared to full table scan. That's what we expect from the explicit index. Very much handy in case of handling large databases having say thousands of rows or millions of rows. That's where the indexing, you can clearly see the apparent distinction between the output response time of the full table scan, which is slightly sluggish, and the output response time of this explicit indexing method, which is bound to be slightly faster. Okay, much more faster. Now, coming down to line number 14, here I am trying to, now another thing, this quick underscore explore. This quick underscore explore is what kind of index? Explicit index. But it has got another name also. That name you will see under the object explorer also after some time. The name is non-unique, non-clustered. Okay, this quick underscore explore is not only known as an explicit index, but it is also known as a non-unique, non-clustered index. Okay, why non-unique? Why non-unique? See, if you come to this city column, then what is the nature of the city column? Let us come back to our original table first. Select it, execute, and see under the city column, if you see, if anyone asks you what is the nature of the city column, Is it a unique column or is it a non-unique column? Then the answer should be it is a non-unique column. The city column is a non-unique column. Why is it a non-unique column? Because here it doesn't have unique values. Here in the city column, it doesn't have unique values. Unique values occur when a column has unique values means in a particular row the value has appeared and it won't get repeated in any of the other rows. That's what a unique column means. But does our city column belong to that category? Does it belong to the unique category? It doesn't. It is a non-unique column because here the values are repeating. For example, Delhi appears in the first row. They appears again in the third row, repeats again in the fourth row, repeats again in this row. Same logic goes for Pune. Appears in the second row for the first time, gets repeated in this row, gets repeated in this row, gets repeated in this row. Same goes for Dehradun also. It may have got repeated. So under the city column, you will have multiple repeating values. Okay, no unique values. That's the nature of the city column. Because logically also it is very much practical because many people they may belong to the same city. Many employees of that organization they may belong to the same city, isn't it? So that is where it's logically correct also that the nature of the city column is non-unique. Non-unique means where it will have repeating values. Okay. And unique column means where there is no repetition. A value appears once, no more repetition, which is not our case here. City column is a non-unique column. Now, this explicit index, quick underscore explore, where am I creating it? I'm creating it on the city column. And since the city column is a non-unique column, hence this explicit index quick underscore explore also becomes also known as a non-unique index. As because I'm creating this explicit index known as quick underscore explore on the city column of the table, where the city column is a non-unique column. Hence, this explicit index quick underscore explore is also known as a non-unique index because I'm creating it on a non-unique column known as city. Okay. That's how the terminology goes. Although it has got a much more longer name, that is quick underscore explore is also known as, which is an explicit index. It is also known as a non-unique, non-clustered index. Quick underscore explore, which is an explicit index, is also known as a non-unique, non-clustered index. Non-unique, I have told you. Why non-clustered? That I will come down a little bit later. So please remember this kind of an index when explicitly being created on a non-unique column of a table like city, then the index, which is my explicit index, is also known as a non-unique, non-clustered index. Now, come down to line number 14. Here I'm trying to create another explicit index. Same line of code, create index command I'm giving to the SQL. Then the name of the index I'm specifying, which is quick underscore explore 1 on which table no emp2 underscore table, and I have to target the column or columns. So inside the parentheses I have to write the column or column names of the table. One is city, another one is addr1 address one, that is this particular column. Okay, city column already I've told you it is a non-unique column, so here also I mean city column is a non-unique column. And what is address one? Address one corresponds to locality. That is also a non-unique column because many people or many employees may not only belong to the same city but may belong to the same address one also, that is to the same locality also. It may happen, isn't it? So the nature of the city column here is non-unique. The nature of the city column is already non-unique, and the nature of the addr1 address one column is also known as non-unique because it may have repeating values, not unique values. So this entire line of code, same code, that is create index. I'm giving command to the SQL create index, giving name of the index like quick underscore explore one on keyword you have to give inside the single parenthesis. You have to write the column names. Two columns I'm specifying here, city and address one, and these two columns belong to which table? emp2 underscore 2 table. So this index, explicit index, will be created jointly. This explicit index quick underscore explore one will be created jointly. It will be created jointly on these two columns, city and address one. Here we have multiple fields, not a single field. Okay, like here we had a single field, but in this scenario we don't have a single field, we have multiple fields on which we are creating our explicit index quick underscore explore one. Okay, So that is why this type of indexing method, which is definitely an explicit indexing method, it is also known as composite indexing method. It is also known as composite indexing method. Why? Because here I am creating a composite index, which is my quick underscore explore one. Why it is a composite index? Because I'm creating it on multiple columns or multiple fields of the table. That's why it is a composite index, and the procedure is known as composite indexing. Now, again, coming back, the city column is a non-unique column. Address one is a non-unique column. Address one is also a non-unique column. Non-unique column means both these columns are going to have repeating values. And based on these two columns, I've created this index, explicit index, quick underscore explore one, which will be a non-unique index only because of these two columns with respect to which I'm creating this index. So this quick underscore explore one is also an explicit index known as a composite index, and it is also known as a non-unique non-clustered index. Why non-unique? Because I'm creating it on these two fields, city and address one, which are themselves non-unique columns. And why non-clustered? That I will come down to later. For the time being, just run this line of code, line number 14, to create. Commands completed successfully. That means quick underscore explore one index has been created. Go to line number 16 and 17. Here what I'm trying to do, select asterisk from emp2 underscore 2. That is display all the fields from this table emp2 underscore 2, and all the fields will be displayed. And which kind of records will be shown here? Only those records will be shown here where the city value is Pune and address one is 5H Karanshe. So line 16 and 17 are selected. Hit the execute button. You see there is only one employee. There is only one employee, Archana Sharma, who belongs to the Pune city and belongs to this 5H Karanshe. Okay. So quick underscore explore one is my composite index, which is an explicit index, and it is also known as your non-unique, non-clustered index. Why non-unique? Because based on these two columns, it was created city and address one, where city and address one are non-unique columns. And same concept goes here also. Quick underscore explore is an explicit index, and this is also known as a non-unique, non-clustered index because this I created on the city column. See where the city column itself is a non-unique column. If you come to this left hand side under the object explorer and select databases, hit the refresh button, expand the databases, and then you come down to your database class 1 where we have our tables, like expand the tables, and the main table is emp2 underscore 2. Expand it, expand the columns. You see columns expanded. Now scroll down, then you see keys. These keys remember hopefully pk01, uk01. We had in the previous classes I had shown you how to create keys like primary key, unique key, then various kinds of constraints on a table. Okay, then come down to indexes, expand it, and here you see quick underscore explore. Quick underscore explore is shown here. It is what? It is an index. What kind of index? Explicit index. And for the detail wise, if you go, it is not only known as an explicit index, but also known as a non-unique, non-clustered index. Non-unique, non-clustered index. And same goes for quick underscore explore one also. This is also an index. Okay. This was an explicit index, and that is it is an explicit index. There is a composite index. And if details wise you go, this is also a non-unique, non-clustered index. Okay. Now, why non-clustered? Why non-clustered? Come to line number 4, select, and I'm trying to come back to my original table. Uh, Look into the bottom right corner, 132 rows are being displayed of this database table. Okay. Now see, city column. This city column, has anything changed in it? In this city column, has anything changed in it? Nothing has changed. Nothing has changed. Whatever was the order, whatever was the order of the physical storage of the data under the city column, it remains intact. It does not get altered, does not get affected in spite of creating this index quick underscore explore, which we had created on the city column of this table emp2 underscore 2. Okay, so under, if you see again at the city column, nothing has changed. That is, the order of the physical storage of the data under the city column remains intact, does not get altered. Why? Because the city column itself does not become the index. The city column itself does not become the index. Rather, this quick underscore explore index, it gets created separately. Okay, this quick underscore explore index gets created separately as an index. Okay, so just remember that the city column itself does not become the index, remains intact. So the order of physical storage of data under the city column remains intact, nothing changes. Rather, this index, quick underscore export that we created, this index gets created separately, and it will basically store the unique values of the city column. This index will store the unique values of the city column. Unique values means basically under the city column you have 58 values of Pune. Under the city column you have 58 values of Pune, and our index quick underscore explore will just have the one value of Pune. And alongside with Pune, there will be associated row pointers. Okay. The job of a pointer is to point out to specific rows wherever a particular value is there. Okay. So under the quick underscore explore, you won't have 58 values of Pune. Like in the city column, you had 58 values of Pune. The quick underscore explore will contain the unique values of the city column. That means it will just have one value of Pune, not 58, but one value of Pune. And alongside with it, there will be associated row pointers. What is the job of a pointer? To point out to those specific rows where we have some values. Okay. So the job of those associated row pointers will be to point out the job of those associated row pointers associated to what? Associated to the value of Pune, which is stored under the quick underscore explore index. The job of those associated row pointers will be to specifically point out to specifically point out those particular rows, those particular rows of the table under the city column where you have the value of Pune. Okay, so those associated row pointers will simply point out to those specific rows of the table where you have the value of Pune under the city column. Okay, uh, so how the values are stored, like here this is my explicit index quick underscore explore, and it will store the unique values of the city column. That is no repetition. If Pune is there in under the quick underscore explore index, then Pune will be there only once. It won't be repeated. It will be just there only once. Similarly, you can have other values of city like Agra. You can have Bangalore. You can have some other values like Chennai. Say, for example, under the city column, there are 12 rows where you have the Agra value. Now, under this quick underscore explore index, it will just have one value of Agra, no repetition of Agra, one value of Agra. And alongside with Agra, there will be associated row pointers, which will specifically point out to those rows of the table where you have the value of Agra under the city column. Okay, and all these values are stored, all these values in the index are stored in the form of a B tree structure. All these unique values of the city column, the unique values, all the unique values of the city column will be stored in this index quick underscore explore in the form of a B tree structure. B tree structure means in alphabetical order. In SQL, this B tree structure means in alphabetical order. So the unique values of the city column will be taken and will be stored inside the index, and they will be stored uniquely. There is no repetition, and they will be stored in an alphabetical order in the form of a B tree structure. Like say A for Agra comes first, then B for Bangalore, then C for Chennai, then D for Delhi, then M for Mumbai, then N for Noida, then P for Pune. Like this, the unique values of the city column will be stored in the index quick underscore explore in an alphabetical order in the form of a B tree structure. Okay. Now, when after creating this index, after creating this explicit index, when you run this query, that is display all the records from this table wherever the city value is equals to Pune. So what will the SQL database engine do? It won't go to the table. It will directly come to the index. Again, I'm repeating, when I'm running this query after creating this explicit index quick underscore explore, then select asterisk from mp2 underscore 2 where city is equals to Pune will display all the records corresponding to Pune. So whenever I run this kind of a search query operation after creating the index, the SQL database engine won't go. It won't go for the full table scan. It will rather come to this index quick underscore explore and it will navigate. It will basically navigate through the B tree structure of this index. Okay, the SQL database engine will come to the index. Once that query is run, the SQL database engine will come to this index quick underscore explore and it will navigate through the B tree structure of this index where the unique values of the city column are stored in an alphabetical order. And the SQL database engine will just look for one value. The SQL database engine will just look for one value, which is Pune. As soon as it finds out Pune, then there are associated row pointers alongside with Pune. Those associated row pointers will then guide the SQL database engine. That is, those associated row pointers will point out to the SQL database engine that these are the specific rows of the table under the city column where the value of Pune is located, and only those specific rows will be displayed. Okay, so the as soon as we run that search query, our SQL database engine will come to the index, will navigate through the B tree structure, and there it will find the unique values of the city column stored in an alphabetical order, and it will just look for one value, which is Pune. The SQL database engine comes to the Pune value. There, the associated row pointers will point out to the SQL database engine. Point out what? Point out to those specific rows of the table where you have the value of Pune under the city column. Okay. So those specific rows of the table will be then displayed. That's what the SQL database engine do. So here in this scenario, did the SQL database engine come to the table? It didn't come to the table. In the case of full table scan, it comes to the table and it will run a full table scan row by row. Here, it did it come to the table? It did not come to the table. So here, did it conduct any row by row operation? It did not conduct any row by row operation. It just got very efficient and the operation got very much efficient because the SQL database engine didn't go through each and every row of the table. It simply arrived at the index, went through the B tree structure, located the value of Pune, then followed the associated row pointers, which guided the SQL database engine to those specific rows of the table where the value of Pune is located under the city column. And then those only specific rows are selected and then displayed. So no navigation row by row. So definitely this explicit indexing is bound to be faster as compared to full table scan. And why non-clustered? As I told you, the city column itself does not become an index. The city column itself does not become an index. It remains intact. Remains intact means whatever is the order of the physical storage of data under this column, that remains intact, does not get altered. Rather, this index quick underscore explore gets created separately. Due to this concept, this quick underscore explore index is known as a non-clustered index also. Okay, so jointly speaking, this kind of an index that you saw here is known as an explicit index, and it is also known as a non-unique, non-clustered index. Why non-unique? As I told you, with respect to the city column, because the city column has non-unique values. And why non-clustered? Because the city column itself does not become the index. The order of the physical storage of data under the city column remains intact. This index, that is quick underscore explore, gets created separately. That is why it is a non-clustered index also. This concept is known as non-clustering. So this quick underscore explore is your an explicit index, also known as a non-unique, non-clustered index. So hopefully guys, you have understood this video, and if you have liked this video, please hit the like, share and subscribe button and hit the bell icon notification button. We shall meet again in the next class. So thank you.